As early as the late 1990s, the United Kingdom foresaw a future where relying on imported gas for energy wouldn't be sustainable. This realization led to the inception of the Hinkley Point C nuclear power station, a monumental project situated in Somerset, England. This massive third-generation nuclear facility, under construction since 2008, is mired in controversy, with its staggering budget of £41 billion drawing criticism from even the most esteemed British academics and experts. Some critics have gone so far as to label it the most expensive endeavor ever undertaken to cultivate a new generation of British nuclear scientists and engineers who would be instrumental in advancing the UK's nuclear-powered submarine capabilities. The latest budget estimates are 3 times the initial projection, and the project is notorious for its delays. It's uncertain if Hinkley Point C will be operational by its revised target of 2028, and there are doubts about its efficacy and experimental nature. Adding to the controversy, the French and Chinese firms involved in the construction are reportedly shielded from any repercussions if the project fails to meet expectations or leads to disastrous outcomes. So, let's delve into this unique, modern nuclear power station. Once operational, it will be the largest of its kind in Europe. We'll explore the various controversies that have made Hinkley Point C a topic of intense debate and scrutiny. Before diving into the engineering and technology behind the colossal Hinkley Point C nuclear project, it's crucial to address the controversies surrounding it. The project is not funded by the UK government, but is a private initiative, with about 70% financed by the French state-owned EDF and 30% by the Chinese state-owned CGN. This financial setup grants these companies significant control, raising questions about the consequences if the project fails to meet its promises or encounters major setbacks. The UK government appears to bear the brunt of any issues, including high costs per megawatt, expected to persist for over 35 years. This is due to the strike price mechanism, which essentially fixes the price the government pays for the electricity generated, irrespective of lower market rates for other energy sources. Initially set at £92.5 per megawatt, the strike price was raised to £106 in 2021. This system allows the project owners to adjust building costs and claim inflation, forcing the government to accept a higher strike price in the future. This aspect was so controversial that even the European Commission expressed displeasure, perceiving it as a scheme that allowed EDF to influence energy prices across the UK and potentially the EU. Another major concern is the detrimental impact on renewable energy initiatives like wind and tidal power, which have become increasingly cost-effective. For context, in 2016, 2 EDF directors resigned in protest against the Hinkley project, reflecting the internal dissent over its viability. To sum up, the project's budget might escalate to £50 billion, with the strike price potentially reaching £150 per megawatt by 2035. Despite this, the UK government seems limited in its response, often issuing complex reports that require expert analysis to understand. The government's rationale is that nuclear power, being non-intermittent unlike solar or wind, is a viable green option that will help achieve the 2050 zero emissions goal and reduce reliance on imported gas. However, this does not justify the enormous costs and the looming monopoly of EDF and CGN over UK power prices, which will affect millions of households and businesses, potentially leading to significant increases in living expenses. This situation poses a potential crisis, threatening to reshape the UK's social landscape and widen inequality gaps. It's a scenario that could lead to societal changes, reminiscent of dystopian films like The Hunger Games. Now, let's shift our focus to the design and construction aspects of Hinkley Point C, the UK's first new nuclear station in over 25 years. Hinkley Point C, covering an expansive area of 430 acres, is set to feature 2 EPR, European pressurized reactors, contributing a significant 3,200 megawatt electrical output. Developed primarily by Framatome, formerly part of Areva between 2001 and 2017, and Électricité de France, along with Siemens in Germany, the EPR represents a third-generation pressurized water reactor design. These reactors are distinguished by their increased safety measures and economic efficiency, offering about 1,650 megawatt electric output per reactor. The reactors are versatile, capable of using 5% enriched uranium oxide fuel, reprocessed uranium fuel, or a full mix of uranium-plutonium oxide fuel, with Areva's M5 zirconium alloy cladding. Key design features include 4 independent emergency cooling systems, crucial for dissipating decay heat for 1 to 3 years post-initial shutdown, a robust, leak-tight containment around the reactor, an additional containment and cooling zone to manage any potential molten core breaches, a dual-layer concrete wall, 2.6 meters thick, engineered to resist airplane impacts and internal pressure variations, Construction preparations began in 2008, starting with a car park for ground investigations. EDF acquired the nearby manor of Sydenham in Bridgewater in 2012. By 2014, a 400-strong workforce was engaged in preliminary works, including infrastructure for construction traffic, worker accommodations, transport facilities, a seawall, and a jetty for material deliveries. 2017 marked the start of the actual plant construction, with initial tunnel networks for cabling and piping. A major milestone was achieved in December 2018 with a 2,000 cubic meter concrete pour, forming part of the first reactor's 4,500-ton base. By 2019, the base of the first reactor was completed with an additional 8,950 cubic meters of concrete, followed by the second reactor's base in the subsequent year. The construction employed the Saren's SGC-250, the world's largest crane, for lifting over 600 heavy components, including the steel containment liner and dome for each unit. In a significant development, February 2023 saw the delivery of the first nuclear reactor pressure vessel, constructed in France by Framatome in 2022 via the Bristol Channel to the dedicated wharf at Comwich. Despite these advancements, the reactors are still under construction and may not reach completion until around 2030. What's your take on the Hinkley Point C nuclear power plant? Do you see it as a strategic economic move and a step forward, or as a costly error that has unfolded over the past 3 decades? Share your thoughts in the comments below. Thanks for tuning in. If you enjoyed this video, don't forget to like, share, and subscribe. Also, click the bell icon to stay updated with our latest content.